Hey everyone, Mr. Newman here, and today we're going to learn about how to solve quadratics a different way. This is by completing the square. Now, completing the square, first we have to identify what is a perfect square trinomial. You see what I did here? I've got some equations. This is something we did last unit where we multiplied binomials. X plus 6 squared, that thing squared, gives you x squared plus 12x plus 36. X squared plus 12x plus 36, we call that a perfect squared trinomial because it's something squared. It's x plus 6 squared. So, any trinomial that is a perfect square trinomial is going to be something else squared. And we're actually going to use that in our strategy of solving by taking the square root. We're going to put those two strategies together and be able to solve equations by completing the square. Just to illustrate this, or to remind you, let's have you multiply x plus 8 squared. Remember, that's x plus 8 times x plus 8. Go ahead and do that real fast. All right, y'all done? You should have gotten something like this. Then distribute the x and distribute the 8. And then don't forget to combine like terms. I do this, first of all, to remind you guys how to multiply, which is very important, but also to notice a few things about these numbers. So let's write that there, x squared plus 16x plus 64. And the other thing I want you to do is I want you to look very closely, and I want you to notice, especially concerning the coefficients or the constants. So that's like this, in this new one, the last two, those are the perfect square trinomials. I want you guys to notice what connections there are between those three numbers that I underlined, the 6, the 12, and the 36. And look at all four equations, all four situations, and figure out, and just type down one or two connections or things you notice. All right, thanks for doing that. Here is what I noticed, and here's the important thing I want you to notice. The constant in the factor is always half of the b term. Now, what do I mean by b term? Well, for every quadratic, you have ax squared plus bx plus c. That b term is always double the constant inside the factor. So this 8 right there that I underlined, double underlined, is always half of 16. The 9 is half of 18. And this negative 9 is half of negative 18. So that always matches up like that. Other thing that's very interesting is that the c term is always the constant in the factor squared. What do I mean by that? Well, this 6 squared is 36. 8 squared is 64. 9 squared is 81. And it even works for the negative number because negative 9 squared is positive 81. That's because a negative times a negative is a positive. So, we have those two patterns, and we're going to use those two patterns to create perfect square trinomials. Let's do this right here below. So if I had x squared plus 10x plus blank, what should go in the blank to make it a perfect square trinomial? Well, the secret is that the perfect square, the thing that you're squared, it's half of that c term. So if I have x plus something, sorry, I said half of that b term is what I meant to say. That 10 right there, half of that 10 is going to be what's going to go inside of those parentheses. Half of 10 is 5, so x plus 5 squared is the perfect square trinomial we're trying to write. And that 5 squared is what's going to be the c term up there. So you square 5 and you get, well, 5 times 5 is 25. So 25 is going to be the end of that perfect square trinomial. Of course, I said, and then factor. Well, but the way we wrote it out like that, we just factored it. So we are good to go there. X plus 5 squared is x squared plus 10x plus 25. Let's try the next one together here. X squared minus 14x plus what is a perfect square trinomial? Well, what is half and then square is the pattern we're going to follow. So what is half of negative 14? Well, it's negative 7. And notice I included the negative, so you need to include that there. And we're going to take that negative 7 and we're going to square that to give the end of the perfect square trinomial. What's negative 7 squared? It's positive 49. And that is our factor. X minus 7 squared is our factor. And the end of that trinomial is the 49 there. Try the next one on your own. All right, did you figure it out? First of all, it's half of negative 2. That'll give us negative 1. And then square negative 1, you get positive 1. And that's how you make a perfect square trinomial. So how do we use this when solving quadratics? Well, what we're going to do is we're going to take an equation, that's anything with an equals sign in it, and a quadratic, and we're going to complete the square, then factor it, and then solve by taking the square root. So let's try that. First of all, you need to notice that this is the format that we're going to have whenever we're doing this. ax squared plus bx equals some constant. So you see over here on the left, we have that set up like this, x squared plus 8x equals 33. And what we're going to do is first we're going to leave room for adding the number to each side of the equation. So remember, ax squared plus bx plus c is our standard form, but here we have the c, we're just going to have it on the other side when we have an equation. You want the constant away from the other variables. So we make these blanks to leave room. Oh, we have a, b, and c there. We have these blanks that I have already drawn for you, but you'll have to draw on your own when you're doing this problem. And you will need to draw a blank on each side because whatever you add to one side, you always must add to the other side. Then we're going to half b, that means take b and divide it in half. So in this case, the b is 8. We're going to make half of that, and half of 8 is 4. So that's the number that we're going to square to fill in the blank here. So 4 squared is 16, so we fill in the blank with 16, but if you add 16 to one side of an equation, you must add it to the other, which is why we have two blanks. Then we're going to factor it. Well, remember that factor is just that 4 that goes inside of the x plus blank, because x plus 4 quantity squared, that x plus 4 squared is x squared plus 8x plus 16. If you take this and multiply x plus 4 times x plus 4, you get x squared plus 8x plus 16. So we factor that, and now on the right side I need to combine like terms, so 33 plus 16 will give me 49. And now we have an equation that we can solve by taking the square root. So let's take the square root of both sides. We take the square root of both sides and you get x plus 4 equals plus or minus the square root of 49. Well, you know that the square root of 49 is 7. So in a second I'm going to replace the square root of 49 with 7. However, we need to get x by itself. So let's subtract 4 from both sides. And when you do that, you get x equals negative 4 plus or minus plus or minus 7, which is the square root of 49. Now, we could leave it like that, but that's not the best way to write it, because what does the plus or minus mean? It means that we have negative 4 plus 7 and negative 4 minus 7. So instead of writing it like that, well, negative 4 plus 7 is 3, and negative 4 minus 7 is negative 11, so those are our two solutions, 3 and negative 11. Let's try this problem. Let's try some of these on our own, because they don't always turn out that straightforward. Sometimes you can leave the plus or minus in, and I'll show you what I mean. So let's try some of these example problems. First of all, x squared plus 6x equals negative 3. You notice what I did here was I left room for adding a number to each side of the equation. What am I going to put in that blank? Well, first I need to do half of b. Half of b is 6, so half of 6 is 3. And then I need to square that. 3 squared is 9. So I'm going to add 9 to both sides. Then I'm going to factor it. Well, factoring is in this case is as simple as saying x plus whatever that half is, so x plus 3 squared equals, we need to combine like terms, negative 3 plus 9 is 6. And now I can solve for x by taking the square root of both sides. Don't forget to write your plus or minus symbol. The square root of 6 is not a nice number, so I'm going to leave it like the square root of 6, plus or minus the square root of 6. And now to get x by itself, I'm simply going to subtract 3 from both sides. So we get x equals negative 3 plus or minus the square root of 6. That's actually the nicest way to write it because we can't simplify the square root of 6. And we're done. You need to recognize that there are actually two solutions in there. It's negative 3 plus the square root of 6 and negative 3 minus the square root of 6. But as long as you know there are two solutions, it's perfectly fine to simply write down plus or minus like we have it right there. For the next problem, we're going to do the same thing. So let's put a blank on each side. What am I going to put in the blank? Well, it's half of b. So half of negative 8 is negative 4. And then square it. Be very careful that negative 4 squared is a positive number. That's positive 16. If you're typing it in the calculator and you're getting negative 16, that's because you're not using the parentheses like you're supposed to. Type in negative 4 in parentheses squared. We added 16 to one side, we also have to add it to the other now. And now that we did that, let's factor it. Well, the factor is simply going to be that negative 4 brought down into the x minus 4 squared. On the right side, we're going to combine like terms, and negative 5 plus 16 is 11. So the last thing we have to do is take the square root of both sides. Have a plus or minus, and now solve for x. Well, we have x minus 4, so let's add 4 to both sides. And we get x equals 4 plus or minus the square root of 11. Once again, we cannot simplify the square root of 11, so we're done here. As long as you remember, we actually have two answers we just wrote down. There's 4 plus the square root of 11, and the other answer is 4 minus the square root of 11. For the third problem here, I don't have it set up like I want it to be. I want all the x's on one side and I want all the constants on the other side. So in order to do that, I need to add 4 to both sides. I'm going to leave a little space here because my next step is to write the blanks in. So let's go ahead and add the blanks. And once you have that, we need to figure out, okay, well, what goes in the blank? Well, it's half of 12, which is 6, and then square that. 6 squared is 36. So I add 36 to both sides. The next step is going to be factoring that, so I'm going to take that 6 and it's just going to be x plus 6 squared. On the right side, we need to combine like terms, and 4 plus 36 will be 40. And let's take the square root of both sides. Don't forget your plus or minus. And I need to subtract 6 from both sides to get my final answer. But we're not done because the square root of 40 is not simplified. True, it's not a perfect square, but it does have a perfect square inside of it. So let's use our skill of simplifying the radical. What is the largest perfect square that goes into 40? It's 4. So let's rewrite it as the square root of 4 times the square root of 10. And then the square root of 4 is 2. So my final answer is negative 6 plus or minus 2 times the square root of 10. And that is my final answer in how you write that last problem. Thank you very much for watching.